Hi, my name is Triana,
And Rafael,
and we are going to present our chemistry project. First, molar mass. What is molar mass? It's a mass in grams of 1 mole of the compound, and the formula is mass, it's equal to mass per mole, it's equal to G per mole. How to define the molar mass of a compound? Step 1. Determinates the number of atoms of each element in the compound. Step 2. Multiply atomic weight of each element with its number of atoms present in a compound. Step 3. Add up all and assign until as grams per mole. Here is an example. In the solution, since sodium carbonate contains 2 atoms sodium, 1 atom of carbon, and 3 atoms of oxygen, the molecular weight should be 106. Next is spectrometry. What is spectrometry? It's a standard and inexpensive technique to measure light absorption or amount of chemicals in the solution. A spectrometer it produces a desired range of wavelength of light. First, collimination transmit a straight beam of light that passes through a macrometer to split into several components wavelength spectrum. Then a wavelength select transmits only the desired wavelength. Photometer. After the desired range of wavelength of light passes through the solution in the covalent, the photometer detects the amount of photons that it's absorbed and then sends a signal to a global meter or a digital display. You need one of these to produce a variety of wavelengths because different compounds absorb best at different wavelengths. Electrogravity. What is electrogravity? The tendency of an atom in a molecule to attach the shaped pair of electrons toward itself. There are two types, across a period and down the group. From left to right, the nuclear charge increases and the atomic size decreases. Therefore, the value of electrogravity increases across a period in the modern periodic table. For example, in the electrogravity trend across the period 3 in the periodic table below. Chemical reaction. What is a chemical reaction? Is in which the bonds are broken within reactant molecules and new bonds are formed within product molecules in order to form a new substance. There are many types, like combustion reaction. A combustion reaction is a reaction with a combustible material with an oxidizer to give an oxidizer product. Then is decomposition reaction. A decomposition reaction is a reaction in which a single component breaks down into a multiple products. Neutralization reaction. A neutralization reaction is basically the reaction between an acid and a base, giving salt and water as a product. Redox reaction. A reduction reaction is a relation in which there is a transfer of electrons between a chemical species. Precipitation or double displacement reaction is a type of displacement reaction in which two compounds react and consequently their anions and cations switch in places, forming two new products. Synthesis reaction. A synthesis reaction is one of the most basic type of reactions wherein multiple single compounds combine under certain physical conditions giving out a complex product.
the atomic radius is defined as half the distance between two adjacent atomic nuclei of an element. From the atomic radius, the size of the respective atom can be calculated. On the other hand, the size of the atom influences changes in state, density, and other properties, such as melting and boiling points. If we look at the periodic table, we will notice that as we move down and to the left, elements have larger atomic radius. This is because as the period decreases, the atomic radius increases, and when the group is leading, the atomic radius decreases. Chemical bonds. Chemical bonds are forces that cause atoms together in molecules, and is the attraction between nucleus of one atom and the electron of another. There are three types, mainly ionic bonds formed between ions, charged particles. One atom donates electrons, becomes a cation with a positive charge, and another atom accepts electrons, becomes an anion with a negative charge. The opposite charge can attract, holding the ions together, and it is from 1.7 to more. Then covalent bonds formed by the sharing of electrons between atoms. Atoms share electrons to achieve a more stable electron configuration. Single, double, or triple bonds can form depending on the number of shared electrons, and it is from zero point 0.5 to 1.7. And at last, metallic bonds found in metals and alloys. Electrons are delocalized and move freely among the metal ions. This results in a sea of electrons that holds the metal ions together, and it is from 0 to zero point 0.5. pH is a measure of the acidity or alkalinity of a solution. It quantifies the concentration of hydrogen ions in a solution. The pH scale ranges from 0 to 14, with 7 considered neutral. Values less than 7 indicate acidity, while values greater than 7 indicate alkalinity or basicity. The pH of a solution is determined by the following formula that it is in the presentation. Then acidic solutions that have pH more than 7, these solutions have a higher concentration of hydrogen ions. The strong acids have lower pH values. Then neutral solutions. Pure water at room temperature is considered neutral with equal concentrations of hydrogen ions and hydroxide ions, and basic or alkaline solutions from 7 to less. These solutions have a lower concentration of hydrogen ions and a higher concentration of hydroxide ions. Strong bases have higher pH values. pH is an important parameter in environmental science. For example, the pH of water affects aquatic ecosystems, and deviations from the optimal pH range can harm aquatic life. pH is crucial for living organisms, as enzymes and other biochemical processes that have specific pH ranges at which they function optimally. Maintaining the pH within a narrow range is essential for biological systems. A combustion reaction is a reaction in which a substance reacts with oxygen gas, releasing energy in the form of light and heat. The equation it is shown in the presentation, and if it has a lot of hydrogen, it can be corrosive. They broke bonds and attract less. Combustion has many practical applications, such as generating power in internal combustion engines, heating buildings, cooking food, and producing energy in various forms, such as heat and electricity. And there is the example of the battery.
Thank you. Hope you like it.